Hi, welcome back to Circuits with Angel. Today we'll talk about multimeters and the functions on most basic multimeters. Also, this is what we'll use to measure, troubleshoot, and test the projects we will build together. So this video is both informative and practical. For electronics hobbyists, multimeters are one of the few essential parts or tooling needed in our toolbox. It is usually used to troubleshoot our circuits when they're not working. And I think it's really important to explain and understand each section of its functions before I get too far in any of my projects. We use multimeters to measure voltage, current, and resistance in our circuits. So in short, it is a measuring tool. And I'll really need to explain this in detail. But before I begin, there are some safety tips. Do not use this on household appliances. Do not stick the leads into electrical sockets. And do not cut any wires you're not supposed to. If you have any issues with your multimeter, please consult an adult. Always remember, safety first. Now, let's learn more about the multimeter settings. Let's go clockwise. First, we start off with the off setting, which turns the multimeter off. You'll want your multimeter back at this setting after every time you use it, or else it drains the battery of the multimeter. The auto off automatically turns it off after 5 minutes of not being used, but there's no need to waste battery or energy. It is a good habit to learn. Next, we have a voltage setting. This is for DC voltage. We can use that to measure voltage in circuits. After that is the AC voltage setting, which we will not be using. We have amps next. This is the setting we will be using for measuring amps, because we have very little amps in most of our circuits. The amps option below is for 20 amps or less, which is still a lot. If we go over 20 amps, we will blow out a fuse in the multimeter, and it won't be able to measure amps again until you replace the fuse. If this has happened, you should talk to an adult or supervisor. After that is more amp settings, then a capacitor tester we don't really need to use, and then a continuity tester, which tests if two things are connecting to each other. Continuity is a path for current flow. If you remember my circuits basics video, where I explained current flow in a circuit means circle, and as long as that circle is complete, there will be continuity. If that circuit is broken, it will have no continuity, and that means it will not work. And lastly, ohms, to measure resistors. That moves this video to the next topic. Often, when building circuits, you'll be frustrated about why your circuits don't work. It is often that your LED is burnt out and you don't know it. One of the coolest things is a diode tester that lets us check if LEDs are dead. This will save you a ton of time when building circuits. You don't want to go through an entire circuit trying to figure out what is wrong, only to find out it was a burnt out LED. It's not cool to waste your time. So I'm going to show you how to check if an LED is burnt out or not, using a handy dandy testing board that we will build ourselves. Let's build one now. If I'm going too fast in the video, don't forget to press pause so you can follow along. We will need 2 jumper wires and 2 alligator clips and 1 breadboard to build this handy dandy testing board. First, we have to clamp the jumper wires to the alligator clips. This can take a minute to do because sometimes the clips are stuck in their plastic sleeves. Then we put the jumper wires in the breadboard across from each other, directly across. We have to make sure they're directly across so we don't make any mistakes when plugging things in. After that, we clamp the alligator clips onto the multimeter's leads. Sometimes the wires are a bit weird and we need to fix them. Then we clamp that on the lead. This white alligator clip's all tangled up, so I have to fix it. Sometimes clamping things on with the alligator clips can be a bit difficult. The lead came out here, so we had to fix that. Wow, the alligator clip is still really tangly. Man, I wonder how it got like that. If we trace the leads, we can make sure that it is connected. From the leads to the alligator clips, and finally to the jumper wire. We can do the same with the other lead. From the lead to the alligator clip, from the alligator clip to the jumper wire. And that's how we build the handy dandy testing board. To measure the LEDs, we have to set up the handy dandy testing board. I did it again, just so you know how to make it. So we clamp the jumper wires with alligator clips. The alligator clips then go to the leads, which are connected to common and the general testing section. Then we plug in the jumper wires, making sure they stay across from each other. If we don't put the jumper wires straight across, we could put in the LED wrong and we could just assume that it is burnt out and we would throw away a perfectly good LED. The setting is diodes and continuity. Continuity looks like a sideways looking Wi-Fi symbol. Remember polarity when you put in the LED. The long leg goes to the positive side and the short one goes to the negative side. My wires are a bit messy, so I have to rearrange them a bit. It can be a bit hard to put in, but it will get in there. This LED was used a while ago, so its legs are a bit bent from sitting around in my shelf. Usually the continuity tester's continuity light would go on, but my multimeter appears to be a bit low on batteries, so that's why it's not doing it. My sisters were playing when I made this video. That's Buddy the Best saying it doesn't work. Now let's put a different LED in. Usually I go through about like 15 of these at a time to make sure they all work and put them in. Now when the LED works, it glows. And there's Buddy the Best saying it worked. And that's how we test LEDs. Another way to troubleshoot circuits is to go to the continuity tester setting. There, you can use this setting to test components or if jumper wires are connected to where they're supposed to be. I have a not working circuit here as my example. We can work backwards to find the part where it is not connected properly by using the continuity tester setting. Don't forget to do this while it is not connected to your battery or power supply. Safety first. This is a simplified example where I test some quick things to show you how it works. Remember not to use it on a live circuit. There are a few more rules, but I'd rather not bore you. And I still have a lot more to go. Expect that in another video. This is the continuity setting. We will be putting that there. It's also the setting where we used to check our LEDs and diodes. Right now, we measure each LED to the resistor, and if the light is on, it is good. The blue LED and the green LED are good. Let's find out about the yellow LED. This is probably the problem since all the other LEDs are good. The yellow LED seems to have its jumper wire in the wrong location. This is the most common problem we find in our circuits, but thankfully it's quite easy to fix. It kind of hurts to take jumper wires out with your nails, so you should probably get a needle nose plier to get the jumper wire out. Alright, now the circuits should be fixed. Let's plug in our 9-volt power supply and check. You should be careful plugging in circuits. Sometimes when you plug in the circuit, the leads come out and they could short circuit each other. Alright, now the circuit is fixed. That's how you use the continuity tester to troubleshoot and fix circuits. To measure volts, we plug in common and then general measuring port. We are making another handy-dandy testing board. We take the leads and plug them with alligator clips. After clamping this many things, it's kind of easier to clamp them. But it still takes some time to clamp them because they're usually stuck in their plastic sleeves. Then clamp the jump wires, which then plug into positive and negative rails. Remember to be specific where you put your leads. If you put them backwards, it will show up as negative in your multimeter. So if you want it to look proper, put it in the right way. We take the power supply's leads and plug them into the power rails, making sure they are the correct polarity. If you put these ones backwards, the same thing happens. We now use the volt setting. The multimeter can be off by 0.1 of a volt sometimes, but it still works great. So it works. Even if we turn it down, if the power supply looks off to you, it's because the display is blinking so fast the eye can't see it blinking, but the camera can. Now let's turn everything off so no short circuits happen. So I'm just going to unplug and roll everything up for the next time I use it. It is important to unplug everything after you're done with things because otherwise it causes short circuits, especially when you're working with live circuits like this one, which can short circuit if I touch both of the power supply leads together. This is how long it will take you to pack up your multimeter once you're done, usually, so don't be surprised if it takes like forever to pack up. Sometimes I use zip ties or rubber bands to keep the leads together so I don't lose them when they're in the box. Now on to the next topic. Now let's measure current. We have to break into an existing and already working circuit to measure the current. You can't measure the movement of electrons if nothing's moving. You must make sure the circuit is complete and powered. Let's plug in the leads. The red lead goes to the 200 milliamp part this time. Let's clamp the alligator clips to the lead, and the other side to the jumper wire. And we do the same for the other lead. There is a lot of clamping and unclamping with the alligator clips in this video, but it helps save us time instead of having to use our hands to hold the leads. It's really hard to use your hands to hold the leads. You have to use your hands and move the tile at the same time. Next, we plug in our power supply. We can measure any of the jump wires, but we are doing the LED. Then we place our jump wires where the LED was. Then we will use this setting to measure current. Make sure to put it at 200 milliamps or else it'll just show a 1, which means the current was too high to measure. We charge and discharge the capacitor, and in conclusion, the milliamps in the capacitor go from around 6.5 milliamps to 2 milliamps. And that's how we measure current. Remember, we have to break into a circuit that's already working and powered to measure current. And next we're measuring resistance. To measure resistance, we must plug in the ports here at common and the general measuring part. Set it to the lowest setting on the ohm range. First, we have to clamp the leads on with the alligator clips. We have to make our handy-dandy testing board again. Well, you may be wondering why I make this handy-dandy testing board so much in one video instead of reusing the same board. It's because I want to show you how to do it, because it takes a while to make and clamping all this stuff is kind of hard. Now we get to clamp on our jumper wires, and after that we can plug our jumper wires into the board and start measuring. Some of these resistors are the same value, so if I take it out before you see it, it's because of that. It's kind of surprising how 90% of the resistors that we use in our circuits are like the same value. Remember to make sure your resistor goes from each jumper wire to the other, because if you don't, then the multimeter won't say you have anything. If the display says you have 1, it means that the resistance is higher than that range, so you have to move your dial up. This is a 10K. We have a lot of 10Ks in our circuits. I'm putting away this resistor in a pile. On a normal day, I would organize them into piles and put them away. I hope this is another 10K because I feel like I'm going to be sorting through at least like 5 10Ks. That's another 10K. As I said, there is a ton of 10Ks in this pile. I can tell from the color bands on this one that it's not a 10K, so I wonder what it is. This value is a very small decimal, so I will turn the dial down. This is a 470 ohm. We also have a lot of those. 470 ohms are used in like 9-volt circuits, where like the capacitor circuit or the relay circuit. We use 470 ohms a lot for circuits with LEDs, like the continuity tester we had earlier in this video. Wow, this is a 48 ohm, a very, very small resistor. I don't know why we even have such small resistors, but I guess it's one of my sister's circuits. Next is a 21 ohm, even less. This one's probably from my importance of resistance circuit with 4 LEDs and burning them out to see on why resistance is so important. I have a video on that and you can go check that out. It's also on my website, so you can go check that out in the links down below. I can already see this resistor is a very high value resistor. This is a 460k ohm. That's a whole lot of ohms. Alright, we'll only do one more resistor because we've measured a lot of resistors. A lot of these resistors have bent legs, so I have to straighten them out. This one seems to be another small one because it's not very high. And that's another 470 ohm. I think that's enough. That's how to measure resistance. Learning how to use the dial can be a bit confusing. You can take your time to practice with a few known resistors in your kit to see how and get the feel for it. And that's it for this video. Wow, this took me forever to make. I really hope I explained this well. If you have any questions, please feel free to email me at my website links down below. But for the purpose of hobby electronics, these are the features of the multimeter we will use. There are other options on the multimeter that we have not explored, like AC voltage and high current loads. Just a reminder not to stick your leads into an electrical socket. You will definitely get hurt. You will definitely get hurt, you and your multimeter too. Even the socket will get hurt. Don't do this. Always remember, safety first. This basic multimeter can do all these applications and is very useful in troubleshooting and fixing electrical problems around the house. Although, if you start to look at household appliances, do so with your parents' permission and with adult supervision, and also not plugged-in appliances. I'll probably make a more in-depth video in the future with the other settings once we start doing more circuits and electronics together. I really want to thank you for watching and see you next time.